G'day, I'm Dr. Kev, and previously I got some feedback from an ex-Formula 1 aerodynamicist about the initial aerodynamic design of Project 171.
Alright, I'll give you some quick thoughts. I reckon you could easily double the load there, 100% separated. You're asking the air to do a lot, because this is rolling up a fat vortex. I'm not sure if this lack of accuracy is from the mesh or from the STL. These rear shoulder arches generate a lot of lift. Huge amount of lateral here. This is like huge drag. I'd go for a different shape, probably go something more like that. I mean, nothing's really working that hard here at all. The car's definitely going to be rear limited. You can crank this diffuser. You could try to reduce noise or you could try to reduce drag, and they'll both give you the same output.
Following his advice, I went away and made some changes to the model, and I've run that model through AirShaper to see if I've made any improvements. The radiator is now more than double the effectiveness it was in the original design. There's also been some slight reductions to noise around the driver. I've managed to find some moderate improvements to the front downforce, but unfortunately at this stage I wasn't able to do much about the rear lift. And the analysis is indicating that the lateral flow around the rear section of the car could be a problem that needs addressing at a later stage. Welcome to Car Design Workshop. When modelling the new car, one of the things I had to address is that the car wasn't legal for registration. In the older version, I was really aiming for a really low deck height on the vehicle to give that sort of sense of a low-slung car, but I had put the lights lower than what the ADRs allow, or the Australian design rules. So that meant all I had to do here was increase the height of those rear lights. And the way I've been doing this in the model is I've been having what I'm calling a hip line for the vehicle, and I just raised that up. And that had a fairly substantial effect on the appearance of the vehicle. In the way I modeled this, it also meant that the front end of the car came up, but in the previous version, there wasn't really enough space for the radiator flow anyway, so I really did need to increase the height of this front lip. One of the things I needed to address with the analysis of the car in AirShaper was the accuracy of the STL model that I was importing. In the first analysis of the vehicle, some of the areas that had fairly low resolution in the STL came up with stripes, say in the pressure plots and so on, and you could really see that the resolution of the model was not really accurately capturing the design intent. So I just increased the resolution of the output from SolidWorks. I actually wanted to export that as a step file rather than an STL, which ends up being a more accurate idea of the geometry that I'm looking for, but I couldn't get the radiator outputting as a watertight model, so maybe something I can deal with at a later stage. Also, as I was going through the results, I finally realized why the model origin was at some weird place. It turns out that the old STL files would naturally have everything as positive coordinates. If I was aware of this a bit earlier, I could have just changed the output from the STL in SolidWorks. And this would have saved me a little bit of math when I wanted to reorientate the moments around, say, the center of gravity or the rear axle. But in the end, this wasn't too much of a barrier. So we can see with the new export that the quality of the mesh is much better, much smoother. We don't see any of these striped lines in the pressure plots. In AirShaper, we had this region near the rear wheels where the mesh had merged the rear tire with the rear underside of the car. Now, most of this was my problem. I had actually made the model so that they were intersecting by accident. So I managed to address this, made a lot more space there, but still ended up with some areas where the mesh was connecting. I don't think this is having a really big effect on the final results. And again, I could have just made more space. I just put what I thought would be enough clearance, but not actually how much clearance there would be in the final car. So while I'd been a little less lazy with my modeling, I was still maybe a bit too lazy. So let's go through one by one the areas of concern that Tom had in the previous model and how this was addressed. One area in the previous models was the headlight region. Now, I hadn't been able to model this particularly well. This wasn't by design. This is some of me just struggling with the surface modeling in SolidWorks. And so there were edges there that were picking up vortices on the original model. Now I managed to improve the modeling a little bit in these regions, and raising that hip line for the car meant that the interaction with the body and the lights was quite a bit different. I'm still not happy with this region. The sort of cutout we're seeing here ahead of the lights is more like a 1960s styling than a 1950s. So this is definitely an area that I want to spend a bit of time getting better in future models. That being said, by smoothing out these regions and removing some of that outside, that exterior part that was quite sharp, there's been a dramatic decrease in the amount of vortices coming off that edge. This is still an area to work on, but happy to at least be making some progress there. There were some other areas that I was really struggling with the surface modeling of this car, and there are some areas where the curvature of the car is not quite right. In the front bumper, there's a region around here that I'm not really happy with. I'm getting a little bit better at surfacing in SolidWorks, and I did try another program that was recommended by one of the viewers, Plasticity. I wasn't able to make great progress in that at this stage, but definitely happy to look at some options to try and improve the surface modeling of the cars for the much later versions. On the first model, I'd really focused on, the exterior, the upper exterior, and immediately Tom went and had a look at the bottom of the car. And I just hadn't modeled it particularly well. So I had a lot of sharp edges around the wheel wells. Some of the detail was missing. I just blocked it out. The radiator inlet was just an open hole to the bottom. And with this, I thought, just leave full opening to the radiator, but it just didn't work. Now, all of these sharp edges and the wheel well area, they just created separation. It's really untidy. In the very first video, I'd largely hidden those details. I didn't really want to show them because I hadn't done a lot of work. But if you've been working in F1 like Tom has, then you're going straight to the underbody of the car and having a look there. So he unveiled all of my horrible secrets. So to address some of this, first of all, I just increased the accuracy of what that model is most likely going to be. I followed through the shape of the chassis at the moment, and I was able to include all of that suspension detail in the analysis. Everything had a radius applied, and I did put a little bit of a vent behind the front wheel to try and vent out any air. Now, this isn't very neat at this stage, but I just thought if I just cut it out, I'll see what it does. It was more of a just see what happens. Now, with a vent there, I could probably do far more around these sections in front of the wheels to create some sort of downforce producing areas, but we'll see as we go on. It's not really the main concern. Now, I didn't put in what Tom had suggested in terms of some vents here, so taking some of these areas of high pressure and venting them into the wheel well, but those are things that could be done at a later date, and there's definitely some space there for things like brake ducts if that becomes something I'm interested in at a later stage. So I think this wheel well is a little bit more accurate than it was. There's still a lot of detailed design to happen on the actual car, so this will be continually chasing some accuracy of modeling here as applied to the aerodynamics. Now, another detail that I added in the front was a really, really small splitter style device. Because I wanted to close in this radiator inlet, I thought, well, might as well create a little bit of a ledge there where we can capture some of that high pressure and really use that, just that low pressure on the underside. Now, this is still fairly separated. This is a harsh edge, even with the rounding on it. It's not that big of a radius, but it does produce some downforce. And overall, the front lift coefficient almost doubled. So we went from a front lift coefficient of 0.118 to 0.201. And this wasn't even really chasing a lot of front downforce. So Tom had mentioned that in his video that it wouldn't be that difficult on this car to produce the front downforce here. And it looks like he was spot on. Given that I'm not wanting this car to be a high aero car, I'm actually really happy with the front lift coefficient in that sort of region. Now, the big improvement in this front area was the radiator. So originally, with this front radiator, I had an opening there that was trying to promote a lot of flow through there. However, if we look at the actual radiator, we see that it's very, very uneven flow. Some of it getting blocked by that number plate that was there. And because of the height of the car at the front, there wasn't really anywhere else to put the number plate. So this meant there was very uneven pressure, very uneven velocity on that radiator. Now AirShaper gives some measures here. So it has a uniformity of the radiator, and we could see with the original one, it was about 70%. And the flow rate was a shade under 0.8 meters cubed per second. Now the pressures are fairly low, and we can actually see that for that radiator, it's not producing a huge amount of drag, it's not producing a huge amount of lift. Now Tom particularly pointed out how this looked on a cross-section of the car, and we could see that that ducting for the radiator ended up with flow that was really quite separated near the exit. Now, the modification to this was a pretty substantial changes. So I kept the same radiator size. I made sure it was better sealed to the duct. I made sure the opening was well defined, put some small radiuses around the opening, and made the opening and exits about half the area of the actual radiator. I tried to make it a more gradual transition from the radiator towards the bonnet or towards the windscreen. And the result of this is quite substantial. So the uniformity of the radiator, or that distribution of velocity and pressure, it became very, very nice, very, very even. And we saw that jump to about 0.9. But what's really impressive is the flow rate through the radiator went from a shade under 0.8 meters cubed per second to nearly 1.8 meters cubed per second. So a massive improvement, more than double the flow rate through that radiator. Now this did have a downside to it. It nearly doubled the drag from the radiator, and it also considerably increased the lift due to the radiator. But given that we'd had gains elsewhere with the downforce on the front end, overall we still had more downforce on the front end. So the lift from the radiator wasn't causing us too much of a concern. And if we look side on through that same cutaway that Tom had talked about, the flow through that radiator is much, much better than it was. There's still a little part of it near the top of the radiator that we're not getting great flow towards. We're not really using that. That's probably going to indicate that we could actually just shorten that radiator. And this is one area where raising that hip line of the car ended up with, an advantage. There was an actual place that we could put a number plate for the car. So a huge improvement to the flow through the radiator, and one of the really big outcomes of this study. Now, another area of concern was the noise on the driver. Now, we saw in the previous study that AirShaper provides a measure of noise. Now, noise is a transient effect, so this is some mock-up that's using turbulent regions, but fairly happy to accept that it's probably a reasonable representation of where the noise is going to be on a car. And what we saw in the original one is that there was a huge noisy region right where the driver's head was. Now, this is not ideal and something I wanted to address. Some of that was by trying to make the radiator flow a little bit more attached so you could drive more flow towards that windscreen, so you would go up and over the driver. Also decided to make a little bit of change to the windscreen, which slightly increased the height, but brought in some of the side sections to stop air coming in and around. Also in that process, slightly brought the side mirrors closer to the body. And what we see is that noise region around the driver is greatly reduced. In fact, most of it is going over the driver's helmet. Now, when driven on the road, that's going to be hair. And I don't actually want my hair blowing all over the place. There's not that much of it to begin with. So this is still an area that we can do some work, but encouraging that some fairly small changes to the windscreen were having a noticeable effect to the noise in those regions. And we noticed with this windscreen region, there was a slight increase to the drag, but also a slight increase to the downforce produced by this. Now, something that was mentioned by a few people watching the videos was the region around the rear roll hoop. And this is a very, very noisy, messy, turbulent area of the car. We could see with the circular cross sections that there was quite a lot of buildup of high pressure on them, really messy flow. And some of the comments from the videos were suggesting maybe putting something like an Aero profile or just profiling those roll bars. And I thought that's a pretty good idea. I wasn't quite happy with the roll bars anyway, so I modeled a very simple teardrop style profile. I also took the supporting cross from those roll hoop support tubes and really built that into this roll hoop structure. Now, this is definitely not going to be CAMS compliant as a race car, but this is not intended as a race car. It is intended as a road car, and I do think this can be made reasonably safe for rollover. Now, when it comes to manufacturing, this would most likely be done as some sort of lightweight cover over a circular tube. A slight aero profile there, slight aero profile on these support tubes, and what we saw is that that region is considerably cleaner. There's a lot less turbulence coming off there, a lot less noise. It's a much smoother flow. In addition, if we look at the forces from these roll hoops, we drop from a drag of 16.8 newtons to 4.6 newtons. Now, overall, these numbers are both pretty small. I'm not sure that it's really worth it from a drag perspective. And in fact, because of the angle that this is hitting this roll hoop, it is actually producing a little bit of lift. Now, nothing to be particularly worried about, although as we'll see a little bit later, lift on the rear end, that's something we're going to have to chase. There's probably a bit more that can be done here in terms of profiling, but I was fairly happy with this change, and I think aesthetically, it's a little bit better anyway. There was some work though that I put in, some basic yaw studies, which indicated this whole back end, it needs a lot of work anyway, including some look at how we can stabilize this car in yaw. So I'd imagine I'm going to do a few iterations in this area of the car. Now, there are a few things on this car that didn't really change much between runs. The side mirrors, not a huge change in the amount of drag, a slight reduction, but not worth speaking about. We did notice that there was, percentage-wise, a decent change to the force on the helmet or the driver's head, although in real terms, it's not a lot. Most of the flow around that is being obstructed anyway, so we're not seeing huge forces there. Drag forces and lift forces associated with the tires, pretty much the same. There was a slight reduction to the drag on the front tires due to that cutout, but not really worth much. Now, overall, with the body of the car, so this is not including the windscreen and the roll hoops and radiator and so on, we had a marked decrease in the amount of drag. We dropped from 183 newtons of drag to 147 newtons of drag. And in fact, we went from lift production on the body to downforce production on the body. Not big numbers, but in the right direction. Now, unfortunately, this was counteracted largely by the radiator. So while we had a reduction in drag for the overall body, because the radiator was working harder, it was now producing a lot more drag. And what that meant is that the total drag force on the old one was 297 newtons, on the new one, 298. So basically no change to the actual drag force. There was a slight improvement to the coefficient of drag, but there was also a slight increase in the frontal area. So those two canceled each other out. Now, as mentioned earlier, we had a decent improvement to the front downforce. We went from a coefficient of lift at the front of minus 0.118 to minus 0.2. And I think if we followed a bit more of what Tom had suggested, we could go a lot further there. We could probably produce far more than we're actually going to want in terms of front downforce for this car. But we went backwards for the rear of the car. Originally, the coefficient of lift on the rear of the car was 0.129. So actually lift, not what we wanted. We wanted a little bit of downforce, which is why we try to put a diffuser in the first place. It just didn't work. And we ended up with 0.206, worse. Now, Tom had suggested to make some changes to the diffuser to try and get it to work effectively. Now, I took out some of the poorly placed strakes that were just fairly random and tried to use the full width of the car as some sort of diffuser style structure. Now, originally I had a shape that was curving upwards and it was fairly gentle. And Tom had suggested, because it's got a fair amount of ride height, you can actually be much more aggressive at the entry to this diffuser and really drive a change of pressure near the front of that diffuser well before it gets to the messiness created by the rear wheel wells. And I thought that's a fantastic idea, really keen to do it. However, the rear suspension and largely the lower A-arm got in the way. I could only do a very shallow diffuser. And because of that, it basically didn't produce anything. Now, it does have a region of low pressure near the start of the diffuser. So at least what Tom had mentioned is something that's actually working. And I do think that the diffuser is producing a little bit better pressure than what we were getting originally. I think a lot of that has been undone by effectively better flow reaching the back end of the car, especially at the top end. So anything that we gained from the diffuser has been more than ruined by this top section of the car having a substantially lower pressure. And we actually see quite a low pressure buildup on the top surface of the car. And this starts to highlight a problem that we're going to have to address in some later videos. I had made the rear wheel wells a little less pronounced, and I think that was a backward step. I think that was a backward step aesthetically, and I think it was a backward step aerodynamically. So I'm definitely going to have to do a little bit of work here. Another thing that I may consider is, can I get the vehicle dynamics that I want, the suspension performance I want, by raising that lower wishbone? The clearance to the engine and gearbox is not the main concern here. It's really just how do you want the kinematics and the low paths for the suspension. Now, being a bit more of a suspension guy, I just put the lower wishbone about as low as it can possibly go. That's going to lower the forces that are going into the upright. But I think there's some compromise that can be made here to try and improve some of this underbody aerodynamics for the vehicle. So even though the rear coefficient of lift has increased, and I think it's largely because of this top surface, I think it's something you could still live with. The numbers are still very small. And for any speeds that we would have on a normal road, that's not going to be a large percentage of the total rear tire load. But if we want to take this car a little bit faster and we want to start modifying it and improving the amount of power that we're having and maybe using this on a racetrack or something, we might experience substantially higher speeds than that. So I still would like to improve this rear lift coefficient. And I want to try and do it as much as possible without adding a wing or a spoiler or a gurney or something like that. That for me is going to be the last option. So there's still a few things we can investigate before we reach there. But I think this area of the car highlights an even bigger concern. And that is, as we've improved some of the front sections of the car and we've improved the roll hoop region and the windscreen, we're actually getting a lot more attached lateral flow over this rear section of the car. This is going to be a problem as the car goes into yaw. The other thing to note, if we're looking at yaw stability of the car, and the center of gravity of the car is about 60% towards the rear, and feel free to go and check out the video on center of mass locations, and that means that the amount of side body area forward of that center of gravity is quite substantial. It's a reasonably long nose, and there's not that much area behind the car. That means that instead of acting like an arrow going through the car where this is going to self-center, it's going to act the opposite way, in that as you get an unstabilizing side load to it, it's going to promote more instability. Now, this is too big a topic to deal with in this video, and really want to address it as its own, is that we need to deal with some of the yaw behavior of the car. Now, very quickly, I did do some yaw analysis in AirShaper. I was able to do a batch run where I altered the yaw angle of the car, and I did that from 0 through to 30 degrees. Now, I did notice as we did that, the coefficient of drag generally increases. You are exposing more of the car to the oncoming air, or the car that's heading forwards, there's just more of it. And we saw that the lift increased. Now, the load on the rear tires didn't actually change that much. It was just fairly consistent lift until we got to about 25 degrees, and then it started to shoot up. We did lose most of that front downforce as we're going. So at least in terms of the vertical loads on the tires, that's probably not a bad thing. That means our static margin or our aerodynamic margin is moving in the right direction for most of that yaw angles until it gets really quite extreme. The really bad part and the really worrying part is when we start to look at the moment in the Z direction. And that just increases almost linearly as a function of yaw. And it means that the car has quite a large moment trying to encourage more yaw angle as the yaw angle's there. That frontal area means that the car is inherently unstable aerodynamically in yaw. Now, this is something that I really do want to consider. I know from experience with the Austin Healey, it's a little bit of an issue. You're getting up to highway speeds and the car feels a little bit darty. It has a long nose with a fair bit of area there and a tapered off back end. So very similar in design. I mean, it's one of the designs that we're trying to sort of copy a little bit. Now, there's a few things that we may do to address this. We might look at doing some sort of fin, and obviously the D-type Jaguar that raced in Le Mans. I'm really seeing from these yaw results why that was so important. You know, if we extrapolate these results to something like 200 kilometers an hour, then no longer, the tires can't even keep the car pointing in a straight line once you get a reasonable amount of yaw. So a fin, putting a fair amount of back area on the car, that might be something that we need to go down. And there's different ways to achieve that sort of structure. Alternatively, we might need to do a longer tail to this. Just try to have a little bit more distance at the back end. Maybe like the car that was supposed to be the successor to the D-type Jag. You know, I think there might be some ways to do some moderate increases to the length of the car at the rear and still have that small car style aesthetic that I'm aiming for. But we are going to have to deal with that at a later video. Another thing to mention is in the process of doing this, I had noticed that AirShaper has a new interface. And I thought it was pretty neat. It caught me out a little bit in the setup because it was a little bit different to what I had used the previous time. But I really appreciated some of the changes to how the results were viewable. And I thought the menu down at the bottom that allowed you to easily select the different types of analysis was a little bit more flexible than what we had before. Now, they also have updated the standard reports that come out. I'm a huge fan of these standard reports. I think that they're a really good summary. And in terms of recording the process of your design, I think they're fantastic. They're a great record. Now, just like the first video that I did on this, I will make the PDFs or the output reports for this available to any of the Patreon members. So if you feel like you want to directly support the channel through Patreon and get some of these sort of calculations and reports and so on that we're producing, feel free to have a look at the Patreon and join up. But we do intend on trying to show as much of the process as possible through the channel. So as always, really keen to hear feedback. Some of the comments from the previous videos have had an impact on the design, and I'm sure that will continue to be the case. And if you want to see more engineering like this and follow the project in more depth, please feel free to subscribe to the channel. Thanks for your time.